Dear students, now we are going to enter into the structure of various oxides of nitrogen. Earlier we have seen preparation of oxides of nitrogen. We have seen oxidation number, their physical state, everything we have seen. Now, what about the structure of oxides of nitrogen? Let me start with N2O, nitrous oxide. What may be the structure? N triple bond N O, this may be the structure. When I make a single bond with oxygen, it is more or less arrow O, that is coordination bond. What do you mean by coordination bond? Both the electrons are given by oxygen, that is the meaning. Whenever I make nitrogen oxygen single bond, you should consider that it is a coordination bond. That means both the electrons are contributed by nitrogen, more or less. Here positive charge is generated and here negative charge is generated, more or less. Alright. So generation of positive charge here and negative charge here. How? That also you should understand. Nitrogen in the outermost energy level has got 5 electrons. So don't forget, more important, it has got 5 electrons. Nitrogen in the outermost energy level. Oxygen 6 electrons. This is the point. With that we can see all the structures. 2, 4, 6 around oxygen, 2, 4 and then 1, 5 electrons around nitrogen. 5 electrons around nitrogen, 6 electrons around oxygen. That you should remember very well. And whenever I make nitrogen oxygen single bond, both the electrons are given by nitrogen. Therefore here positive charge will be generated and here negative charge will be generated. Without spending anything, a bond is formed. Nitrogen gives both the electrons and oxygen is making the bond. Now all the 5 electrons of oxygen are used. How? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For this nitrogen, only 3 electrons are utilized, one lone pair. So you can understand? Now, oxygen around it has got 6 electrons. All the 6 electrons are present as such without any damage. All the 6 electrons are remaining with oxygen. One pair, second pair, third pair, and a negative charge. So that is about structure of N2O, and it can resonance structures I can give. Resonance structures. How? The resonance structures can be. How can the resonance structures be? The electron pair may be migrated here. The electron pair can be migrated here, and therefore this pair may get migrated here. Alright. Electron pair, if it migrates, you will be getting double bond. Yes. So what will be the product you will be getting? N double bond O, only 2 pair of electrons. Another pair is utilized for formation of bond, N double bond N. Now it has got 2 pairs of electrons. It is positive and it is negative. This one becomes positive and this one becomes negative. How? Now oxygen has got 6 electrons. All the 6 electrons are utilized. Nitrogen has 5 electrons, 1, 2, 3, 4, 5, 6 extra electrons is got, therefore negative. This nitrogen has got 5 electrons around it, 1, 2, 3, 4. 1 electron is lost. Where? A coordination bond is formed between nitrogen and nitrogen. This bond, both the electrons are given by nitrogen, that is the meaning, therefore plus negative. If you start to think, you will be understanding, you will be appreciating. Alright. Now, nitric oxide, NO. NO is nitric oxide. How can we arrive at the structure of nitric oxide? N double bond O, nitric oxide. N double bond O. That is nitric oxide. How can we justify the bond? Nitrogen in the outermost energy level has got 5 electrons. Out of 5, only 2 are utilized for the bond formation. Remaining 1 lone pair. 1 more electron is also over nitrogen. So very peculiar with the nitric oxide. The structure is very peculiar. Oxygen in the outermost energy level has got 6 electrons. Out of 6, 2 here, 2 more here and 2 more here. 2, 4, 6 around nitrogen, 2, 4. But what is happening? One more bond is formed with these 3 electrons. Actually 2 electrons have to get involved in forming bond. 1 electron, odd electron is present, and therefore we draw the bond in the form of dotted line. So this is how we give the structure for nitric oxide. Very peculiar. Actual bond, it has got an electron pair, 1 electron here over nitrogen, double bond, O, 2 electron pairs. If we start to write this bond getting involved in electron pair, and this one also, 3 electrons are making a bond. 2 center, 3 electron. Sorry, 1 center, just around the 2 atoms. 3 electrons are scattered over. Therefore, the bond for nitric oxide is given like this. Actually, it may be given like this. We give the structure of nitric oxide like this. It is very peculiar and very different. Then, N2O3, nitrogen sesaoxide or dinitrogen trioxide. How can the structure be? Let me draw like this. N bond N. Whenever we draw N bond N, let me give you a single bond, N bond N. 3 oxygen, one can be a double bond, one can be a single bond. One can be a double bond, another one can be a single bond. If only one bond means it can be a double bond. But when we draw single bond between nitrogen and oxygen, in what way it has to be? Here, over nitrogen plus, over oxygen minus. How we, how? Nitrogen in the outermost energy level has got 5 electrons, 1, 2, 3, 1 lone pair. Alright? Oxygen in the outermost energy level has got 6 electrons, 1 pair, another pair, 4, 5 and 6. 1, 2, 3, 4, 5, 6. For nitrogen, 1, 2, 3, 4, 5. For this nitrogen, 1, 2, 3, 4, shortage of 1 electron. Why? Both the electrons are given by nitrogen, plus minus. Nitrogen gives the electron. I said coordination bond. Bond is towards this side, and therefore negative charge. All the 6 electrons are of oxygen will be remaining over oxygen. No electron of oxygen is utilized for the formation of bond. This is how. I can give resonance structure also. If I give resonance structure, it will go like this. Bond electron pair may migrate here, and the electron pair may migrate here. So that N double bond O is not disturbed. 2 lone pairs around oxygen, 1 pair here over nitrogen, bond N. Here it becomes double bond and it becomes single bond. Therefore, 3 electron pairs over here and only 2 electron pair over here. It is positive charge and it is negative charge. It is positive charge and it is negative charge. This is how we give the structure for N2O3 and N2O4, dinitrogen tetroxide. What may be the structure? NO2 we didn't see, NO2, nitrogen dioxide. Then only dinitrogen tetroxide. NO2. If it is so, you will be getting structure like this. N, double bond O at one side, single bond O at another side. Single bond O means towards, it is just like coordination bond, both the electrons are given by nitrogen and therefore it is negative charge. Negative charge will be concentrating over nitrogen and positive charge will be concentrated over nitrogen. Negative charge over oxygen, positive charge over nitrogen. All the 3 electron pairs will be over oxygen. Here, out of 6, only 2 electrons are involved in bonding, remaining 2 pairs. It is NO2. Alright. Again, I can go for resonance. How? The negative charge, that is electron pair, may be migrated here. Therefore, the bond may go over here. So, we may get the bond like this. N, single bond O, electron pair, electron pair, electron pair, double bond N, only 2 electron pairs. Therefore, Here minus, here plus. That's all. That is about nitrogen dioxide. If we go for N2O4, now I think you can write the structure yourself. You can try. How? Let me give you a clue. N bond N. Remaining O2, another O2. How? Single bond O, double bond O. Double bond O, single bond O. That's all. N2O4, N2O3. So oxygen, single bond means negative charge. Single bond means negative charge. Single bond means 3 electron pair. 1, 2, 3. 1, 2, 3. Double bond means only 2 electron pair. Only 2 electron pair, 4 electrons. And nitrogen should get positive charge. Why? And negative charge is found over oxygen. Therefore, it is positive. It is also positive. That's all. Very interesting. If you go for resonance, can be written from single bond, electron pair of oxygen here, and bond will go as electron pair. Bond is becoming electron pair is becoming bond. Bond is becoming electron pair. Likewise, also here, the double bond. The bond here may be shifted here. Therefore, it may happen. If it happens, nitrogen, these two nitrogen charge over nitrogen will not get disturbed, and you may get the structure like this. N, here double bond, here single bond, here another nitrogen, here nitrogen, double bond here, single bond here. If single bond means negative charge, if single bond means negative charge, and over single bond 3 electron pairs, 1, 2, 3, 1, 2, 3. Here 2 electron pairs, 1, 2. Here 2 electron pairs, 1, 2. That's all. Finished. And finally N2O5. Dinitrogen pentoxide with 2 nitrogen, 3 oxygen atoms. That means an oxygen is present in between. That's all. Nothing else. An oxygen atom is present in between. Same thing. Put an oxygen in between. N-O-N. Make a double bond. Make a single bond. Make a double bond. Make a single bond. Just double bond, double bond. I made opposite. Usually it will be the case. And here negative charge. Here positive charge. Here positive charge. Here negative charge. And here 2 lone pairs. Here 3 lone pairs. Here 2 lone pairs. Here 3 lone pairs. Oxygen here, 2 electrons are utilized, 2 lone pair. That's all. That's all. And you can go in for resonance if you want, otherwise no need. Resonance in what way? The electron pair may get migrated here. You can try for resonance structure. It is negative charge is here. So electron pair may be migrated here, and therefore bond may go here. That's all. So what may be the other structure? Resonance structure. You try, you write. It will be N-O-N. Double bond here, double bond here. Single bond here, single bond here. Over single bond negative charge, over single bond negative charge. 2 electron pair, 3 electron pair. 2 electron pair, 3 electron pair. 2 electron pair. That's all. That is about various structures of oxides of nitrogen: N2O, NO, N2O3, NO2, N2O4, N2O5. In the next session, let us go into oxyacids of nitrogen. Thank you.